Unit testing. You know you're doing it wrong. You know you are. Because it's a pain and you hate it, which is what tells you that you're doing it all wrong. Why do I say that? Well, let's take a look at that. So, everyone knows that we all hate to do unit testing. Testers think that it's a developer's problem because it's really code related and they can't understand it. Developers feel like it's testing, so it's something that the testers should be doing, which I kind of get. But the truth is that developers really need to do unit testing. And the reason that they hate it isn't so much that it's hard to create unit tests, it's that it's a pain to maintain them, to keep them working. What we find is we create a whole bunch of unit tests, they all work fine this release, and next release comes along and everything starts breaking. Now there's a lot of reasons why things break, and in some cases it's legitimately that the software is changed or is actually broken, which is what a unit test is supposed to point out. But a lot of other things are just getting noisy and they're failing when we look at them and go, well, it's okay that that failure happens. And what happens over time is that number of things that fails edges up from a couple in a test suite to 2%, 5%, 10%, 15%. At what point are we getting dangerous where we're accepting test failures and think that it's okay? And this is really the big thing. Many years ago, my brother and I were working and he created this little test harness to run our tests. And at the end of the test execution, he would sum up the total and say, well, 90% success, ship it. And if it was, 75 to 90, he'd say, you better take a look before you ship it. And if it said below 70, he'd say, hey, you need to fire somebody. And it was kind of a joke, but the truth is that we make decisions like this all the time. So we need to have a unit test suite that we can rely on, that we know it represents what we need it to. So there's a couple of common mistakes people make when they're setting up unit tests and they can't rely on them. And it's really important because now we're in a continuous world where we want to build continually, we want to deploy automatically. And in order to do that, we basically need a binary decision coming out of our testing, meaning it needs to say go, no go. Now, go, no go doesn't have to mean 100% test success, but it might mean 90, it might mean 95, it might mean how much coverage do we have. So the common mistakes, I would say, number one is test coverage. It's shocking to me how many people aren't measuring their test coverage in unit testing. I'll ask something like, so how good's your unit testing? And they'll say, well, I have 20,000 tests. I don't know if that's good or bad. If those 20,000 tests represent 15% of the functionality, it's probably bad. It's probably way too many. If they represent 300% of the functionality, it also is probably way too much. So it's more important to understand what are they covering. Now I get it. Coverage isn't the be-all, end-all measurement of software quality, and it shouldn't be. But lack of coverage is actually a meaningful metric, because if we're not covering something, then what are we testing? And if a large part of our application is not covered, then what are we shipping? So number one, making sure that your tests are providing good coverage and not a lot of overlapping coverage. Number two is making sure that you have assertions. It's shocking to me again how often someone will say, well, the test executes and as long as it doesn't crash, it passed. I've had more than one argument with a developer over whether or not a unit test without an assertion is really a unit test. And I still adamantly say no, it is not. If it's just executing the code, then it's just execution. What you're really saying is if it doesn't crash, it's okay. That's a pretty low bar to set for application quality. So have an assertion, meaning the unit test should have some meaning. It should have one of three things it means. One is the software is okay because I've checked this particular functionality and it works. Another is the software is not okay because I've checked this particular functionality and it didn't work. Or the third is, hey, this thing's failing and I know that this thing is failing. I need to go check it out and see whether or not this is critical. So it's important that you have assertions that you can tie back to real functionality, that you understand what they mean. So when a unit test fails, you can trust it. When it passes, you can trust the application. And when the unit test does fail, that you get enough information that you know where to go chase the thing. Way too often I've talked to organizations where it takes them up to 2 weeks to take a unit test failure and actually remediate it in the code. And a lot is trying to figure out, is it real? Where did it happen? What's going on, etc. So meaningful assertions resolve both of those issues. Another big one is people accepting a certain level of failures, and I see that all the time. Someone's got 20% of their tests that fail. They've been failing for years, 2 years, 5 years, 10 years. It's part of a legacy application, and they've always failed. By the way, don't get me started on legacy. Go watch my last video. You'll see what I'm talking about. But what happens is that we get used to, let's say, 10% failure rate. And we know that we've always shipped with this 10% failure rate. So it's okay as long as we don't have 11%. Now, there's some real dangers in that. And one is that maybe I fixed a few of those, like 1% of them, and I created 1% new errors. But because we expect that 10% are old errors, we've missed the new errors. It's like running spell check for the first time on an industry-specific document. Every word unique to your industry gets messed up and underlined, and the real errors can't be found. Your unit tests needs to be running clean. The tests need to be on things that aren't brittle so that you can trust your tests. And here's the thing about an old, noisy legacy test suite. People have this funny attachment to these tests that they don't listen to and don't trust. By this I mean, if I go to you and I say, hey, you've got 10% of the tests that are failing, why don't you fix it? And the developer might say, well, they might be important someday, we know that they fail, so it's okay. And I say, turn them off. Just stop running them. Oh, I can't do that. Those tests are important. Those tests are indicating failure. Is that important? Well, no, that failure is okay. So these tests aren't very useful, are they? And it really throws people for a loop, but it's a real good idea, because we're all doing code that's got old test suites probably, to look hard at any tests that are failing. If you have a ton of them, I'd take a really strict approach. Just turn off any test that's failing all the time that you're ignoring anyway. You might want to measure coverage before and after and see if your coverage drops, and this is what scares people. But the truth is, if you have coverage without meaning, a test that's constantly failing is the same as a test without an assertion. So it's one of the easiest ways to get your test suite under control. Stop running tests that you ignore. Yes, your coverage might go down, but your new coverage number will be more representative of what you're really doing, and therefore much more valuable and much more safe. So I wrote a blog about this a while back with some really good steps. I'll put a link to it below, but let me know what you think. Thumbs up if you liked it. Leave your comments, your questions, and subscribe to the channel for more information. Thanks.